Imagine standing on the surface of a world where one half is coated in shining white ice, reflecting starlight like a mirror, while the other half is cloaked in ancient darkness, absorbing all the light that touches it. That's Iapetus discovered in 1671 by the astronomer Giovanni Domenico Cassini. Iapetus puzzled scientists even back then. He noticed that the moon was visible only on one side of Saturn and not the other. The mystery? It was literally hiding part of itself centuries. Later, we found out why. Iapetus is two-toned, with one hemisphere dark as coal and the other bright as a glacier. It's as if someone painted one side with night and the other with day. But why? Some believe the dark side is coated in dust from another moon, Phoebe-like cosmic soot carried by space winds. Others think the difference goes deeper. A story locked in Iapetus's very birth, no matter the reason. This strange duality makes Iapetus one of the most visually unique moons in our solar system. It's like a yin and yang, floating in frozen silence. Close your eyes and imagine drifting slowly through space. Past Saturn's glowing rings, where silence wraps the stars in an eternal hush. They're floating among the outer moons, lies something peculiar. Half of it gleams brightly like snow. The other half is cloaked in darkness, as if night itself has taken root on one side. This is Iapetus, one of Saturn's strangest moons, and perhaps one of the solar system's most mysterious bodies. At first glance, Iapetus doesn't look real. It resembles something out of science fiction. Perhaps that's why many people call it the Death Star moon. They're not. Far off, its surface features an enormous ridge, a wall that wraps around the moon's equator like a stitched seam. This equatorial ridge stretches over 1,300 kilometers long and rises nearly 20 kilometers. High in places that's taller than Mount Everest. But how did this ridge form? That's where the mystery deepens. Some scientists believe the ridge could be the remnant of a collapsed ring that once orbited the moon itself. Yes, a moon with its own ring. Over time, that ring may have spiraled inward, gently raining material down in a straight line. Others suggest internal forces, maybe even ancient tectonic activity or the freezing of a once squishy core. Push this ridge upward from within, and then there's the dual color. Iapetus is uniquely two-toned. One hemisphere is as bright as freshly fallen snow, while the other is as dark as charcoal. It's believed that this contrast comes from space dust, dark particles from another Saturnian moon, Phoebe coating one side of Iapetus as it orbits. That dark surface absorbs sunlight, warming it just enough to cause ice to sublimate and shift to the other. Brighter side reinforcing the contrast over time. It's like a natural yin and yang, suspended in the cold silence beyond Saturn, floating. Through space, it spins slowly, just enough to tease astronomers for centuries. We only began to understand Iapetus more clearly after NASA's Cassini spacecraft gave us a close-up in the early 2000s. Before that, strange ridge and dual coloring were just fuzzy hints through Earth-based telescopes. But even now, Iapetus keeps its secrets. Why only this moon? Why does the ridge match the equator so perfectly? Could it be the frozen skeleton of a vanished world? Or a clue to Saturn's chaotic early years? In a dream, you might imagine walking that ridge, sharp cliffs on one side, a sudden drop into shadow on the other. You'd see Saturn's rings glowing in the sky like a jeweled halo, and behind you, half the world would be bright, half swallowed in night, a moon of halves, of mystery, of symmetry and strangeness. And, in this peaceful orbit far from Earth, Iapetus turned slowly, still keeping its ancient secrets, still waiting to be fully understood. Floating in the cold, outer reaches of the solar system is a moon so massive, so quietly magnificent, that it dwarfs entire planets. It's not a world of fire or fury, nor is it a place that demands attention. But if the planets were to line up in a row, this silent satellite would outshine more than one of them. Its name is Ganymede, and it is the largest moon in the solar system, even bigger than Mercury, orbiting around Jupiter. The gas giant, known for its violent storms and swirling clouds, Ganymede carries with it a quiet power. Its diameter stretches over 5,200 kilometers, making it nearly 8% larger than Mercury, a planet in its own right. And yet Ganymede is classified as a moon, bound not to the sun, but to its mighty parent, Jupiter. Scientists believe Ganymede is not just a frozen rock. Beneath its surface, of water, ice, and ancient scars, lies something far more extraordinary: a possible subsurface ocean. Hidden beneath tens of kilometers of ice, this ocean could be salty, vast, and even warm in places. Heated from below by the moon's own internal energy, that means that Ganymede might not only be big, it might also be alive with motion. With liquid tides, and perhaps even with the building blocks of life, the surface tells its own quiet story. Great bands of grooves stretch across vast ice plains, likely caused by tectonic-like movement below. Some regions are heavily cratered, ancient and untouched for billions of years. Others are smoother, suggesting more recent activity. It's a frozen record of time, layered in silence and distance. Unlike most moons, Ganymede has something else truly special: its own magnetic field. No other moon in the solar system has this. It creates auroras near the poles, interacting with Jupiter's powerful magnetosphere in ways we're only beginning to understand. When the solar wind rushes past, the auroras flicker, dancing in alien skies no human has ever seen. When imagined alongside Mercury,
Ganymede size
becomes more than a fact. It becomes a statement that even within the quiet role of a satellite, greatness can emerge. While Mercury bakes in sunlight, airless and blistered, Ganymede spins slowly in cold shadow, with oceans beneath and a hidden heart that may still churn. It's not the only giant moon either. Titan, Saturn's largest moon, is also bigger than Mercury, but Ganymede stands as the Titan among moons, a reminder that the categories we assign in science don't always capture the soul of what a world truly is. In 2030, the JUICE mission from the European Space Agency is expected to arrive near Jupiter, focusing much of its study on Ganymede. It will observe the surface, search for oceanic signs, try to understand how such a moon could have evolved so independently, so mysteriously. Until then, Ganymede remains distant, but not forgotten. It spins softly in the vastness of space. Larger than a planet, quieter than a whisper, holding oceans within, and mysteries still untouched. In the silence between Jupiter's thundering clouds and the distant stars, Ganymede waits. A moon, but more than a moon. A gentle giant drift. Mars, the red wanderer of the solar system, carries a pair of companions that seem almost too small, too misshapen to matter, yet they orbit faithfully. Like quiet guardians of an ancient world, their names are Phobos and Deimos, two of the tiniest moons in the solar system. Unlike the smooth, spherical elegance of Earth's moon or the icy glow of Europa, these two look nothing like traditional celestial bodies. In fact, they look more like potatoes than moons, lumpy, irregular, battered by impacts over billions of years. Phobos, the larger of the two, measures only about 22 kilometers across, while Deimos is just 12 kilometers wide. They could both easily fit within the borders of a small city, and yet they orbit a planet that has captivated humanity for centuries. Phobos orbits so close to Mars, it's just 6,000 kilometers above the surface, that it zips around the planet in less than 8 hours. It rises in the west and sets in the east, multiple times each Martian day. To stand on the surface of Mars and watch Phobos rise would be to witness a moon moving at unbelievable speed across a dusty pink sky. Deimos is gentler, slower, and farther away. Its orbit takes over 30 hours, and it barely moves in the sky. It glows softly, a feint against the Martian night, easy to miss unless you're paying attention. But how did Mars end up with such strange little companions? It's one theory is that Phobos and Deimos weren't formed around Mars at all. Instead, they may be captured asteroids, wandering objects from the asteroid belt that strayed too close and were ensnared by Mars' gravity. Their irregular shapes and low densities support this idea. Unlike the icy moons of the outer solar system, Phobos and Deimos seem to be made of dark, carbon-rich rock, the same kind often found in primitive asteroids. Captured, but not yet secure. Phobos, in particular, is in trouble. It's slowly spiraling inward, pulled ever closer to Mars with each passing orbit. In about 50 million years, it will either crash into the Martian surface or break apart, forming a temporary ring around the planet. A moon on a countdown, a ticking cosmic clock drifting through time. Deimos, meanwhile, is slowly moving outward, inching away from Mars over eons. Both moons are covered in craters. Phobos has a particularly massive scar, the Stickney crater, nearly half the moon's diameter. The impact that created it nearly shattered Phobos completely. The rest of the surface is littered with grooves and dust, shaped by microimpacts and thermal stress. With almost no atmosphere and barely any gravity, even a small pebble kicked up could fly off into space. In their stillness, these moons tell stories of chaos and capture, of collisions and quiet decay, of a solar system where even the smallest objects carry meaning. And though they are small, Phobos and Deimos have inspired science fiction for over a century. From early Martian invasion stories to modern interplanetary missions, they remain symbols of mystery. NASA and other space agencies have planned missions to land on these moons and perhaps one day use them as stepping stones for deeper exploration of the Martian system. They may be potato-shaped and faint, but they orbit a planet that might one day become our second home. And as Mars turns slowly beneath them, Phobos and Deimos continue their dance to unlikely moons whispering across the Martian sky, silently keeping watch over the red planet below. Among all the planets in the solar system, none is as delicate, as graceful, or as surreal as Saturn. With its sweeping rings and golden hues, Saturn seems almost like a mirage, too perfect to be real. But there's one strange truth about this giant that defies our everyday sense of reality. If you could find a bathtub big enough, Saturn would float. This isn't a poetic exaggeration. It's a real scientific fact. Saturn is the least dense planet in the solar system. Its average density is about 0.69 grams per cubic centimeter, less than the density of water. That means if you dropped Saturn into a hypothetical, unimaginably massive ocean, it wouldn't sink. It would bob gently, like a colossal golden balloon drifting across a sea of stars. But how can a planet so massive be so light? The secret lies in its composition. Saturn is a gas giant, made almost entirely of hydrogen and helium, the two lightest elements in the universe. While Saturn is over 95 times more massive than Earth, its volume is so immense that its overall density ends up being less than water's. Picture it, a world without a solid surface, where pressure builds as you move inward, turning gases into liquids and then into metallic forms deep within. You could never stand on Saturn. You'd fall through its clouds, crushed long before reaching any kind of floor. It's a planet of layers, each stranger and more intense than the last. Floating is more than just a whimsical fact. It tells us something profound about planetary formation. Saturn's low density reveals that it formed in the outer solar, a system where the sun's heat was too weak to drive away light gases. There, beyond the frost line, hydrogen and helium could gather and grow, slowly swelling into a world that now glows with pale yellow beauty. And then there are Saturn's rings wide, elegant and almost impossibly thin, made of billions of tiny ice particles, dust, and rocky debris. The rings only enhance Saturn's otherworldly charm. They stretch out more than 280,000 kilometers, but in many places are only tens of meters thick. When sunlight hits them just right, they shimmer like frost under a full moon. To imagine Saturn floating isn't just an abstract exercise. It creates a sense of cosmic poetry. You might picture a dreamlike sea on a distant world, soft waves rippling as Saturn rests gently on the surface, its rings casting moving shadows on the water. The planet reflects golden light while the surrounding sky holds a quiet gleam of distant stars. Science makes such images feel strangely real. Saturn also has winds fast, patterned, and complex. In its upper atmosphere, Winds can reach over 1,800 kilometers per hour, shaping clouds into bands and swirls. At the North Pole lies the famous hexagon, a vast, six-sided jet stream that defies easy explanation. It's a structure so stable and geometric that it seems artificial, yet it's completely natural, a result of fluid dynamics on a planetary scale. All of this, in a planet that would float, it makes you wonder what it truly means for something to be massive. Saturn may be large in size, but it carries itself lightly. It holds rings of ice, moons of all kinds, from frozen Enceladus to cloudy Titan. And still, it's lighter than water. There's something peaceful in that. While other planets roar with heat and fury, Saturn remains quiet, silent, dreamlike, suspended between reality and imagination. It is in many ways a symbol of cosmic balance, a giant that floats, a world of gas with elegance carved into every curve. So if you ever feel the need to believe in something gentle, remember Saturn, the only planet that would float. Not because it is empty, but because it is light. A drifting giant in a sea of gravity. Far beyond the warmth of the inner planets, past the swirling storms of Jupiter and the golden halo of Saturn, lies Neptune, a distant azure world wrapped in wind and silence. And orbiting around it is something even more peculiar. A moon that refuses to follow the rules of motion. A moon that moves backwards. This moon is Triton, the largest of Neptune's satellites. And it holds a distinction unlike any other large moon in the solar system. It orbits Neptune in reverse. While most moons orbit their planets in the same direction that the planet itself rotates, a natural consequence of how solar systems form, Triton moves against Neptune's spin. This type of orbit is called retrograde, and it's incredibly rare, especially for a moon so large. The motion itself is mesmerizing. Imagine Neptune slowly turning in one direction, its delicate blue storms swirling across its surface. And then picture Triton carving its own path in the opposite direction, like a rebel orbiting backward through time. This strange dance isn't just unusual, it's a clue to Triton's past. Scientists believe that Triton wasn't born around Neptune at all. Instead, it was likely a wanderer, a captured object from the Kuiper Belt, a vast region of icy bodies beyond Neptune. Long ago, Triton may have been part of a binary system, two icy worlds orbiting each other. As they passed near Neptune, a gravitational tug may have pulled one in and flung the other away, trapping Triton in orbit, but it didn't settle quietly. Triton's capture was violent. Its retrograde orbit destabilized Neptune's early moon, a system likely destroying or scattering other moons in its path. Over time, friction and tidal forces caused Triton's orbit to shrink and become more circular. But it never lost its backwards path, a permanent scar of its cosmic abduction. Today, Triton is more than a mystery of motion. The most geologically active moons in the solar system. Despite its incredible distance from the Sun, Triton has a thin atmosphere, mostly nitrogen, and even active geysers. These cryovolcanoes spew nitrogen gas and icy material into space, forming dark streaks across the surface. Voyager 2, the only spacecraft to visit Triton in 1989, captured haunting images of this strange, frozen world, icy plains, dark ridges, and a surface so smooth in places, it appears almost new. Beneath its frozen shell may lie a subsurface ocean, warmed by internal heat caused by tidal flexing, the same process that warms Europa and Enceladus. Even here, at the edge of the the sun where the sun is just a pale star, the ingredients for life may still linger below the ice. Triton's surface is unlike any other moon. It's coated in frozen nitrogen, giving it a bright, reflective appearance. Its temperature is one of the coldest measured in the solar system around, -235 degrees Celsius. Yet beneath this stillness is movement, activity, and the quiet heartbeat of a moon in motion. But Triton's story isn't finished. Due to its retrograde orbit, Triton is slowly spiraling toward Neptune. In billions of years, it may come so close that tidal forces tear it apart, forming a massive ring system around Neptune. What is now a lone icy traveler may one day become dust and ice. Another chapter in the planet's mysterious history. A moon orbiting backwards. It sounds like something from a dream, and in many ways it is. Quiet anomaly, distant and cold, telling a story that stretches across the solar system's age. Its rebellion is not loud or violent. It is steady, slow, and sure. Triton continues its lonely loop, orbiting in reverse, writing its history in silence across Neptune's twilight skies. Our solar system isn't drifting through space unprotected. Even though the stars may appear still and the void may seem endless, the sun casts a silent shield across the darkness, an invisible, ever-expanding bubble that wraps around every planet, moon, comet, and asteroid in our celestial neighborhood. This protective shell is called the heliosphere, and it's one of the most gentle, unseen miracles of our existence. The heliosphere is formed by the solar wind, a constant stream of charged particles that flows outward from the sun in all directions. These particles move fast, brushing past planets and flowing far beyond Pluto, and though they are invisible to the eye, they carry the sun's influence across billions of kilometers. Eventually, this solar wind meets the soft pressure of interstellar space, the place where the galaxy's own winds and particles begin to push back. Where this quiet standoff occurs, the edge of the heliosphere is born. It's not a wall or a hard shell. Instead, it's a transition, a whisper in the void. A region called the heliopause, where the solar wind slows, bends, and finally fades into the galaxy. This bubble, vast and unseen, is our true border, the outer edge of the sun's kingdom. Every planet, from rocky Mercury to icy Neptune, orbits inside this gentle shield. Even distant Pluto, with its lonely elliptical path, stays safely wrapped within the heliosphere's quiet protection most of the time. But how do we know it's there? The first real confirmation came from two of humanity's most distant travelers, Voyager 1 and Voyager 2, launched in the 1970s. These spacecraft were never meant to last this long, yet they kept going, passing planets, watching moons, and continuing their journey into interstellar space. In 2012, Voyager 1 became the first human-made object to cross the heliopause. The instruments detected a sudden drop in solar particles and a rise in galactic particles, proof that it had entered the space between the stars. In 2018, Voyager 2 followed, sending back similar data. These crossings marked the first time, touched the edge of the bubble we live in, the moment we stepped outside our sun's reach, and still, the heliosphere drifts onward. It isn't static. Like a flame in the wind, its shape changes based on the sun's activity and the pressures of the interstellar medium. Some scientists believe it's not a sphere at all, but more like a teardrop, flattened at the front and trailing off behind as we move through the galaxy. What does it mean to be inside a bubble? In everyday life, bubbles are delicate, temporary things. But the heliosphere is resilient, a quiet protector that shields us from dangerous cosmic radiation and high-energy particles from deep space. Without it, Earth's atmosphere could be stripped away by galactic winds. Life as we know it might never have had the chance to emerge. The heliosphere acts as a cosmic filter, softening the harshness of the galaxy's raw energy. And while we can't see it, feel it, or hear it, it's always there, a gentle reminder that even in the vast, cold spaces between stars, there is structure, motion, and a kind of care. To imagine the heliosphere is to imagine a glowing orb, gently floating through a starry sea, planets spinning within, like tiny boats sheltered from the current. Outside, the galaxy waits beautiful and vast. Inside, the sun's breath carries warmth and rhythm, guiding us through the Milky Way. And one day, as our technology grows, we may explore more deeply, sending ships not just across planets, but beyond the heliopause into true interstellar space. But for now, we drift gently inside the sun's silent bubble, rocked by the waves of solar wind and held in the arms of something unseen. The heliosphere isn't just science. It's a lullaby of motion, the breath of our star whispering across space, cradling the worlds it created. Not all companions in space are giant planets and dazzling moons. Sometimes even the smallest travelers, the rocky wanderers of the solar system, carry little partners of their own. It may sound strange, but it's true. Some asteroids have moons. It's easy to picture moons orbiting planets. Earth has one. Jupiter has dozens. But an asteroid, just a chunk of rock drifting between planets, doesn't seem big enough to hold anything in its orbit. And yet some do, like quiet dancers locked in miniature spirals. These moons circle their parent asteroids in silent, ancient rhythms. The first discovery of such a pair came in 1993, when NASA's Galileo spacecraft passed by an asteroid named Ida on its way to Jupiter. To everyone's surprise, the images showed not just Ida, but a tiny companion trailing alongside it, a moon later named Dactyl. This was something completely new, an asteroid with its own satellite. Since then, astronomers have found over 150 binary or multiple asteroid systems. Some consist of an asteroid with a single moon, others have two or even more. A few systems are almost equal in size to rocks orbiting a shared center, like slow-motion figure skaters tethered by invisible thread. These tiny moons, often no more than a few hundred meters wide, orbit surprisingly close to their asteroid hosts. They don't have smooth paths like the moon around Earth. Instead, their orbits are delicate, vulnerable to disruption. A stray collision or gravitational nudge could send them drifting off forever into space. But how do these moons form? Some may have been captured, like space debris drawn in by chance. Others were likely born from collisions. When asteroids smash into each other, as they often do in the crowded asteroid belt, the impact can send fragments into orbit. Over time, some of these fragments settle into stable orbits, becoming moons. Another possibility involves spin. When sunlight heats an asteroid unevenly, it can cause the rock to slowly spin faster, a phenomenon known as the YORP effect. If it spins too quickly, the asteroid may begin to shed material, flinging chunks into orbit. These fragments can eventually become small satellites. Whatever the origin, the result is the same. A tiny moon following its partner through space, both of them caught in the gravity of the sun, both part of a quiet cosmic waltz. Even more fascinating are the mission images we've captured. NASA's Dawn spacecraft, Japan's Hayabusa missions, and most recently, NASA's DART mission, all gave us close-ups of these rocky duos. The DART mission in particular was historic. It purposefully collided with Dimorphos, the moon of an asteroid named Didymos, to test how we might deflect a dangerous object heading toward Earth. For the first time, we not only watched a moon around an asteroid, we changed its orbit. That's more than science. That's cosmic choreography with purpose. Imagine drifting past one of these asteroid systems. The asteroid itself might be rugged, cratered, spinning slowly under distant sunlight. Nearby, a tiny moon circles gently, casting a soft shadow on its partner, then disappearing into the blackness again. No sound, no wind, just gravity, patience, and motion. These moons may never make headlines like Saturn's rings or Mars storms, but they are quiet reminders of the solar system's complexity. Even the smallest rocks hold secrets. Even the loneliest travelers are not always alone. In the stillness of deep space, where the stars are cold and far apart, a tiny moon circling. A silent asteroid is like a whisper of connection, gravity's way of saying, stay close. Not all companions are loud or large. Some are just there, orbiting gently, unseen by most, but very real. Moon for a rock, a shadow for a wanderer, and a reminder that space, even at its smallest scales, is full of wonder. Beyond Neptune's orbit, past the last of the giant planets, and deep into the icy black, lies a region so vast and quiet it almost feels forgotten. Yet in this lonely frontier, a delicate band of ancient worlds gently drifts, circling the sun. At the very edge of its reach, this is the Kuiper Belt, a sprawling, icy realm filled with thousands of Pluto-like objects, and it holds some of the oldest, most untouched material in the entire solar system, discovered in theory long before. it was ever seen, the Kuiper Belt remained hidden for most of human history. Only in the 1990s did astronomers begin to confirm what had long been suspected, that Pluto wasn't an oddity, but the first of many similar worlds waiting quietly in the dark. The Kuiper Belt is a disc-shaped zone, stretching from about 255 astronomical units from the Sun. To put that in perspective, Earth is 1 astronomical unit away from the Sun, Pluto, around 39 astronomical units, and the Kuiper Belt continues even farther. It's like a shimmering ring of frozen worlds, far beyond what we used to call the last planet. And Pluto. It's just the beginning. Pluto is the most famous of these distant wanderers, but it's far from alone. Other dwarf planets like Eris, Haumea, Makemake, and countless smaller bodies, known as Kuiper Belt objects (KBOs), populate this region. Some are round and icy. Others are elongated, tumbling slowly through the dark. Many are too small and faint for us to even detect yet, hiding behind the shadows of space. What makes the Kuiper Belt so special isn't just the number of objects it contains, it's their origin. These are pristine relics from the birth of the solar system. Unlike planets that have melted, collided, and reshaped themselves over billions of years, Kuiper Belt objects have been frozen in time, left untouched in the cold vacuum. They're like a cosmic museum, preserving the ingredients of the early solar system in perfect, icy silence, and in that silence, motion continues. Some objects in the Kuiper Belt have eccentric orbits, tilted or stretched by the gravitational pull of Neptune. Others follow more orderly paths, like Pluto, which has a resonant orbit with Neptune that prevents them from ever colliding. There are even theories that something larger may be lurking far beyond the Kuiper Belt, a massive, undiscovered planet called Planet 9, whose gravity might explain some of the strange orbital patterns observed in distant objects. The idea that there could be another world, still unseen, out there in the dark, shaping the dance of icy bodies, stirs both science and imagination. The New Horizons mission gave us our first up-close look at Pluto, revealing a world with mountains of water ice, heart-shaped plains, and hazy skies. But it also gave us something more, a glimpse of the mystery and beauty that awaits in the Kuiper Belt. After Pluto, New Horizons visited Arrokoth, previously called Ultima Thule, a small, snowman-shaped KBO over 6.5 billion kilometers from Earth. Its surface was red with organic compounds, its shape untouched since the dawn of the solar system. No atmosphere, no erosion, just quiet existence floating for eons. It's hard to describe the serenity of this region. There are no storms, no blinding sunlight, no tidal waves. Just frozen worlds turning slowly, illuminated only by a pale sun that barely casts shadows. Their motion is deliberate, their paths ancient. If you could stand on one of these icy worlds, you'd see stars like pinpricks in every direction. Sun would look like a distant star itself, still present, but no longer commanding. In the deep stillness, time would seem slower, and you'd feel something unique, the gravity of forgotten things. Worlds left behind, but never lost. The Kuiper Belt reminds us that space doesn't end with the planets. It stretches farther, colder, quieter, filled with secrets and stories we've only just begun to uncover, and within it, the echoes of formation still drift. Beyond the frosty, crowded orbits of the Kuiper Belt lies something even more haunting, a region where space stretches wider, the stars seem farther, and celestial bodies are scattered like whispers in a deep dream. It's called the scattered disk, and it is one of the most remote and mysterious parts of our solar system. Here, everything feels different. The objects are fewer, more isolated, their paths wildly unpredictable. Unlike the smoother orbits of planets or Kuiper Belt objects, the members of the scattered disk drift on chaotic, elliptical journeys, sometimes taking hundreds or even thousands of years to complete a single loop around the sun. This strange space is not empty, not truly. But compared to the Kuiper Belt, it feels hollow, stretched, vast. It's like standing in the middle of an ancient ruin. The shapes are still there, the structure faintly visible. But the life is distant, the density sparse, and the inhabitants of this region. They are known as scattered disk objects, SDOs. These icy wanderers are believed to have once been part of the Kuiper Belt, but were flung outward by the gravitational influence of Neptune in the early chaos of the solar system's formation. In those early days, Neptune's migration outward acted like a great gravitational paddle, stirring the icy soup of the outer solar system and flinging pieces into far-flung orbits. Now these SDOs drift in paths that are strange and lonely. Some come close to the sun before slingshotting out into deep space for centuries. Others remain forever in the distant cold, barely affected by the warmth of our star. Their orbits are tilted, stretched, and unpredictable, a silent ballet of cosmic memory. Among these scattered wanderers is Eris, once considered the 10th planet. It's nearly the same size as Pluto, but orbits far more distantly, and its discovery helped define the term dwarf planet. Eris is so remote that sunlight takes over 9 hours to reach it. Imagine that. A place where the sun is just a dot in the sky, dim and cold. And then there are objects like Sedna, whose orbit is so long and stretched that it takes over 11,000 years to complete a single revolution. When Sedna is closest to the sun, it's still farther than most known planets ever travel. And when it reaches its farthest point, it disappears into the dark beyond the known edge, into what may be the doorway to the Oort cloud. The scattered disk isn't just a faraway curiosity. It represents the transition zone between the orderly chaos of the Kuiper Belt and the vast near-mythical expanse of the Oort cloud, where comets are born and the edge of our solar system truly begins. Because of its distance and low density of objects, the scattered disk is incredibly hard to study. Telescopes must look for the faintest, slowest moving dots of light, watching over weeks and months to detect their motion. But each new discovery tells us more about the solar system's past, about the turbulence of planetary migration, the power of gravity, and the quiet endurance of icy bodies and deep time. It's also here that Planet 9, the hypothetical massive world thought to exist far beyond Neptune, might be hiding. Some astronomers believe the unusual orbits of scattered disk objects are being subtly shaped by the gravity of this unseen giant. A ghost planet herding icy debris in a region of silence. To imagine the scattered disk is to imagine solitude. A dark, distant field where frozen fragments of early creation drift alone, circling slowly, untouched for billions of years. The silence here isn't emptiness, it's depth. The kind of stillness that comes from age, distance, and mystery. It's a place where gravity whispers instead of shouts, where orbits don't loop neatly, but stretch like fading echoes across space. And though these objects are scattered, they are not forgotten. They are the outermost members of our extended family. Distant, mysterious, and still writing the story of how our solar system came to be. Among all the planets orbiting our sun, the giants with their swirling storms, the ice worlds on the edge, the gas globes that could float in water, there is one planet that carries a quiet secret deep in its core. Earth is the densest planet in the entire solar system. At first glance, it might not seem that remarkable. Earth is not the biggest, nor the smallest. It doesn't have rings or endless storms or moons by the dozens. But it holds its own kind of power, a quiet intensity hidden beneath its familiar surface, a deep gravity, compact strength. Earth's average density is about 5.51 grams per cubic centimeter. That's heavier, gram for gram, than Jupiter, which outweighs all the other planets combined. It's denser than Saturn, which could float in water, and denser even than Mercury, which is almost all metal. What makes Earth special isn't just what it's made of, but how those materials are arranged. Our planet's structure is layered like a cosmic fruit, from the thin crust we walk upon to the viscous mantle, all the way to a solid iron core wrapped in a swirling sea of molten metal. That inner core, spinning slowly within the heart of the Earth, is small but extraordinarily heavy. It's this central concentration of iron and nickel that gives our planet its immense density. In its magnetic field, beneath mountains and oceans, lies this hidden heart. A weight so great that it shapes the planet's gravity, holds our atmosphere, anchors the oceans, pulls the moon into a perfect, slow waltz. In contrast, gas giants like Jupiter and Saturn, while much larger in size, are made mostly of hydrogen and helium light elements that don't compress easily. Their size is impressive, but their mass is spread thin. Earth, by comparison, is tightly packed, compact, and grounded. Density gives us more than just numbers. It gives us stability, thanks to Earth's dense core. We have a strong magnetic field, which deflects solar winds and cosmic radiation. Without it, life on the surface would be exposed to deadly particles. The same core fuels the tectonic plates, the movement that shapes continents and fuels volcanoes. The dynamic engine beneath the calm surface. This density also affects escape velocity, the speed needed to break free of Earth's gravity. It's part of what keeps our atmosphere wrapped around us, holding in the oxygen we breathe, the clouds that rain, and the warmth that sustains life. It's an invisible grip, strong but balanced, allowing life to flourish without being crushed or left adrift. Among the 8 known planets, Earth is the only one known to support life, and perhaps it's no coincidence that it is also the densest. That compact strength may be part of what makes life here not just possible, but enduring. There's a strange poetry in that. To imagine Earth from space is to see a blue marble, spinning softly in the sunlight. But to understand Earth from within is to know it as a dense, humming orb, filled with heat, gravity, and motion. A world that clings to its atmosphere, holds tight to its moon, and pulses gently with the rhythm of an ancient molten core. We often look to the stars for mystery, but right beneath our feet lies one of the greatest truths in the solar system. We are not just alive, we are anchored by density, by weight, by the quiet strength of a planet that holds everything we know in a tight and perfect balance, in the stillness of night. As you drift into sleep, remember that your dreams rest on the densest planet in the solar family, a place of gravity and light where oceans cling, air moves gently, and the core whispers softly, never ceasing. Imagine standing on a distant, cloud-wrapped world. The sky above you isn't blue, it's heavy, golden and thick with toxic mist. The surface beneath your feet is scorched rock, forever baking under an oppressive atmosphere. You wait. Wait, and still, the sun does not rise. You're on Venus, and here time moves differently. Venus, often called Earth's sister planet, is about the same size and made of the same rocky materials, but that's where the similarity ends. 4. While Earth spins briskly, rotating once every 24 hours, Venus takes its time. So much time, in fact, that a single day on Venus lasts longer than its year. Let's break that down. A year on Venus, the time it takes to orbit the Sun, is just 225 Earth days, but a Venusian day at the time it takes the planet to complete one. Full rotation on its axis is a staggering 243 Earth days. Yes, a full day is longer than a full year. It's one of the strangest rhythms in the entire seventh. And if that weren't curious enough, Venus rotates backwards, unlike most other planets which spin counterclockwise, as seen from above the North Pole. Venus spins clockwise. So if you could see the sun from the surface, it would appear to rise in the west and set in the east. It's opposite from Earth. But don't expect to actually see the sun. Venus is wrapped in a thick, permanent blanket of sulfuric acid clouds so dense that sunlight barely makes it through. And yet these clouds trap heat like a greenhouse gone mad. Venus is the hottest planet in the solar system, with surface temperatures around 465 degrees Celsius, 869 degrees Fahrenheit, hot enough to melt lead, hotter even than Mercury. Though Venus is further from the sun, and beneath those clouds, a stillness unlike anything you've ever known. The surface air pressure is over 90 times that of Earth, equivalent to standing more than a kilometer under the ocean. Space probes that have landed there survived only minutes before being crushed, melted, and silenced. But let's come back to time. Why does Venus spin so slowly? Why does it turn in the opposite direction? The truth is, we don't fully know. Some scientists believe that long ago, Venus may have been hit by a massive object, something that slowed it down or flipped its rotation entirely. Others think tidal forces from the sun may have gradually twisted and decelerated its spin. Still others suggest complex atmospheric effects and internal dynamics at play. Whatever the reason, Venus ended up with a rhythm so strange, it borders on surreal. Now here's where it gets even more fascinating. While a sidereal day on Venus is 243 Earth days, that's one full rotation. The time between sunrise is called a solar day is only 117 Earth days. This happens because of the interplay between its slow spin and its orbit. So, even though Venus rotates slowly, the sun actually appears to rise and set twice per Venus year. The result is a planet where time loops like a spiral, where days crawl and years race, where the clockwork of heaven runs in reverse. Imagine living there. You wake up in eternal twilight. The sky is orange, glowing faintly. You wait for the sun, but it doesn't come. You grow old before it finally peaks over the hazy horizon. A lifetime could pass between dawn and dusk. Time as you know it loses meaning, and yet somewhere beneath all that heat and pressure, Venus may still hold secrets. Some scientists believe it may have once been Earth-like, with shallow oceans and a gentler climate, but a runaway greenhouse effect fueled by carbon dioxide may have boiled away all its water, leaving it scorched and bone dry. A warning, perhaps, from a sister planet that fell too far out of balance. Today, Venus fascinates astrobiologists, not because it's habitable, but because its upper atmosphere might hold hints of life. High above the deadly surface, in the cool, drifting clouds, temperatures and pressures are milder. In 2020, a team of scientists detected phosphine, potential signature of microbial life, though it remains controversial. Still, Venus continues to whisper, not loudly. Not in explosions or light, but in time, in the slow turning of its body and its backward dance around the sun, in the haunting truth that a day here lasts longer than a year. So tonight, as you drift into sleep, think of Venus spinning slowly in silence. A planet that redefined our sense of time. A place where sunrise may come once in a lifetime. A world lost in golden clouds and endless heat, and yet still orbiting, still turning, still dancing beneath the sun, in a rhythm only it knows. Imagine standing on a distant, cloud-wrapped world. The sky above you isn't blue, it's heavy, golden and thick with toxic mist. The surface beneath your feet is scorched rock, forever baking under an oppressive atmosphere. You wait. Wait, and still, the sun does not rise. You're on Venus, and here time moves differently. Venus, often called Earth's sister planet, is about the same size and made of the same rocky materials, but that's where the similarity ends. 4. While Earth spins briskly, rotating once every 24 hours, Venus takes its time. So much time, in fact, that a single day on Venus lasts longer than its year. Let's break that down. A year on Venus, the time it takes to orbit the sun, is just 225 Earth days, but a Venusian day at the time it takes the planet to complete one. Full rotation on its axis is a staggering 243 Earth days. Yes, a full day is longer than a full year. It's one of the strangest rhythms in the entire seven. And if that weren't curious enough, Venus rotates backwards, unlike most other planets which spin counterclockwise, as seen from above the North Pole. Venus spins clockwise. So if you could see the sun from the surface, it would appear to rise in the west and set in the east. It's opposite from Earth. But don't expect to actually see the sun. Venus is wrapped in a thick, permanent blanket of sulfuric acid clouds, so dense that sunlight barely makes it through. And yet these clouds trap heat like a greenhouse gone mad. Venus is the hottest planet in the solar system, with surface temperatures around 465 degrees Celsius, 869 degrees Fahrenheit, hot enough to melt lead, hotter even than Mercury. Though Venus is further from the sun, and beneath those clouds, a stillness unlike anything you've ever known. The surface air pressure is over 90 times that of Earth, equivalent to standing more than a kilometer under the ocean. Space probes that have landed there survived only minutes before being crushed, melted, and silenced. But let's come back. To time, why does Venus spin so slowly? Why does it turn in the opposite direction? The truth is, we don't fully know. Some scientists believe that long ago, Venus may have been hit by a massive object, something that slowed it down or flipped its rotation entirely. Others think tidal forces from the sun may have gradually twisted and decelerated its spin. Still others suggest complex atmospheric effects and internal dynamics at play. Whatever the reason, Venus ended up with a rhythm so strange, it borders on surreal. Now here's where it gets even more fascinating. While a sidereal day on Venus is 243 Earth days, that's one full rotation. The time between sunrise is called a solar day is only 117 Earth days. This happens because of the interplay between its slow spin and its orbit. So, even though Venus rotates slowly, the sun actually appears to rise and set twice per Venus year. The result is a planet where time loops like a spiral, where days crawl and years race, where the clockwork of heaven runs in reverse. Imagine living there. You wake up in eternal twilight. The sky is orange, glowing faintly. You wait for the sun, but it doesn't come. You grow old before it finally peaks over the hazy horizon. A lifetime could pass between dawn and dusk. Time as you know it loses meaning, and yet somewhere beneath all that heat and pressure, Venus may still hold secrets. Some scientists believe it may have once been Earth-like, with shallow oceans and a gentler climate, but a runaway greenhouse effect fueled by carbon dioxide may have boiled away all its water, leaving it scorched and bone dry. A warning, perhaps, from a sister planet that fell too far out of balance. Today, Venus fascinates astrobiologists, not because it's habitable, but because its upper atmosphere might hold hints of life. High above the deadly surface, in the cool, drifting clouds, temperatures and pressures are milder. In 2020, a team of scientists detected phosphine, a potential signature of microbial life, though it remains controversial. Still, Venus continues to whisper, not loudly. Not in explosions or light, but in time, in the slow turning of its body and its backward dance around the sun, in the haunting truth that a day here lasts longer than a year. So tonight, as you drift into sleep, think of Venus spinning slowly in silence. A planet that redefined our sense of time. A place where sunrise may come once in a lifetime. A world lost in golden clouds and endless heat, and yet still orbiting, still turning, still dancing beneath the sun, in a rhythm only it knows.
you.